Welcome to Ask and Learn.
Okay, so for this problem, let's start by figuring out what's given and then what's required. It sounds like a difficult problem, but if you just focus on what's given and what's constant, even if you don't completely understand how population growth works, you can actually figure it out because you don't really need to know much detail unless you're in that area. So what's given here is dy dt, which is actually the rate of change of the population mass. Y is in kg and in kilograms, and the time is in years. And here k is a constant, and m is also a constant. Okay, so m here is given, and k here is given. And we're also told that the population mass at time 0 is 2 times 10 to the 7 kg. So we're going to use this whole thing to figure out first what is y of t, which is the mass of the population at a given time. So the given time here is 1 year. So first, let's rearrange the actual equation. So what I did here is take this here and basically rearrange it. So when we rearrange it, you get 1 over y times 1 minus y over m dy equals kt. So I'm just putting, the y's on one side and the t on one side. It's just same variables on the same end. So again, rearrange a little bit farther. I'm just putting, just factor like the m to the top, basic factorization, and that will give you here at the bottom 1 over y plus 1 over m minus y dy equals k dt. So now it's in a form that we recognize and we can actually integrate it. So remember that the integral of 1 over y is ln of y, or the absolute value of ln of y. So here at the top of the page, I have the result, which is in logarithmic form. Note that I put the negative here so that we can rearrange things in a way that would be easier to solve. So the negative, it would allow me to put it in a fraction form, which is what we want here. See that? So C is a constant that I just added. Okay, so now let's take the, from the log to, let's take it to exponential form. So m minus y over y equals plus or minus e to the constant and then e to the negative kt. So because here e to the minus c times plus or minus, that's just a constant, I can just abbreviate it by a letter a. Okay, so next step is just rewriting it. I'm just simplifying it into an easier form to look at. So by the end, when you reorganize the whole equation, you're going to get y of t equals m over 1 plus a e to the minus kt. So now we have the equation for the biomass at a given time. So we can go ahead and find the actual value for year 1. So we're given, before we do that, we have to find A because we don't know A. But to do that, we're given the value of the mass at time 0. So we use that to find A, So if you rearrange this equation here, you're going to end up with A equals the m over y0, which is at time 0, the mass at time 0 minus 1. So you will find A equals 3. All right. So now finally we can find the mass at year 1. We're just plugging in numbers. Note that m and k, they're constants, and time equals 1. So when you put all the numbers, you will find out the mass equals 3.2 times 10 to the 7 kg. So this is part A. The next part is finding the time when y of t, or the mass, equals 4 times 10 to the 7. So we've already done the hard part in the previous part. We already know the equation for the biomass to find the biomass at a given time. But here we're told the exact amount of the mass at a given time. We don't know the time. So when you plug in the numbers here, you're going to end up with the only unknown variable here is t. Okay. So when you put the numbers in, you're going to end up with e2 minus kt equals 1 over 3, which is a simple number that you can just do a quick arithmetics and you find t. So I just rearranged a little bit here on the next step. Then now you can see time equals ln of 3 divided by k. K is a constant, which is like 0.71, I believe. So that will give you the final answer for the time, which is 1.55 years to reach about 4 times 10 to the 7 kg. Okay, so hope this is clear. I know I wrote everything out beforehand because I don't have writing app. Hopefully this is clear. Okay, thank you.